Welcome back, everybody. In this second video on fraction multiplication, we're going to look at some of the meanings of multiplication that apply to actually whole number multiplication as well. We'll look at how to develop the formula for multiplying fractions, that is the procedure for how you do it, and then see a couple of examples. So let's get started with the meaning for multiplication. And this part pertains really to working with whole numbers. Multiplication, you can think of as adding quickly, you can think of it as repeated addition, or as making copies of something. As an example, 3 times 4, as you know, is 12. We can think of that as we're adding together 4s 3 times. The 4 in the parentheses indicates what's being added together, and the 3 tells you how many times it's being added. Okay, of course, you could look at this as saying that we're adding together 3s, and we're adding together 3s 4 times, and that, of course, is going to equal 12 also. So that's nice. As an application, let's think about cookies. Cookies are always good. Let's say that cookies come in boxes of 24. If you have 2 of those boxes and each of them holds 24, that sounds like 24 plus 24, or 2 times 24, or 48. 5 boxes would be 5 of those 24s, and that would be 120 of those cookies. So basically, we're taking a number 24, the number of cookies we have, and we're taking copies of it, or repeatedly adding, so that you're not doing like kid and writing 24 down 5 times and adding it all up, right? Nobody wants to do that. So multiplication is a way of adding quickly or repeatedly adding. When you're multiplying by a fraction, it takes a different kind of way of thinking. We're going to think of multiplication by a fraction as taking a part of an amount. That is, if you were to take 1/2 times 24, it's hard to really think about how can I add 24 half of a time. It's kind of awkward and hard to think about it that way. So instead, we'll think of it as taking a piece of something. Let's say that you got one of those boxes of 24 cookies and you ate half of it. Okay, well, we're told in elementary school a lot of the time that of means multiply, so that's consistent with what we've got here. Half of 24 is the same as half times 24. Half of 24 is going to equal 12. Okay, I'll leave it to you to go draw out 24 cookies, or go get 24 actual cookies and separate out half of them. Half of those 24 cookies is going to be 12. Okay, a quarter of a box, again, if you think about the 24 cookies, a quarter of the box is going to be 6 cookies. And if you're thinking, well, yeah, that's the same as 24 divided by 4, yes, there's, of course, a really close relationship there. 24 divided by 4 is 6. 1/4 times 24 is 6. Okay, 2/3 of a box. Okay, 2/3 of a box. There you might think, okay, well, let's take the 24 cookies and put them into 3 equal piles. Okay, that's 24 divided by 3, or 8. And so if you take 2 of those 8s, it's going to be 16. Okay, 2/3 of a box is going to be 2/3 times 24, or 16. Okay, a little bit more on that. 1/2 times 24 is 12, and that's the same as 24 divided by 2. 1/4 times 24 was 6, we've seen, and 6 is the same as 24 divided by 4. And then 2/3 times 24 is 16, and that's the same as 48 divided by 3. So what I'm getting at here is, if we were to multiply the numerator of the fraction, like in this last one, we had 2/3 times 24. If you multiply the numerator of the fraction by the whole number, 2 times 24 is 48, and then put all of that over the 3, you'll get 48/3. Here, the other 2 are less fun because the numerators are 1, but that's okay. 1 times 24 is 24. That goes on top, and then the 4 goes on the bottom. It turns out that we can think of that pattern in general, and here I'm going to use letters stand for numbers, and that's just to illustrate the pattern. Okay, I'm going to call this helpful fact number 1. Okay, if A, B, and C all represent any numbers you like, as long as the C is not equal to 0, then if you were to multiply the whole number A times the fraction B over C, then you would get the same as AB, A times B, all over C. Here's another little example. If you wanted to take 3 times 9/7, this is going to be 3 times 9, or 27 over 7. Okay, multiplying a whole number times a fraction, you'd multiply the whole number times the numerator and put it all over the denominator of the fraction. And that's going to, what we're going to call helpful fact number 1. All right, so now we're done with the meanings of multiplication for the moment. What we want to do next is actually work on the development of how you actually get multiplication of fractions done. And we're going to start by doing a simpler case where we have just numerators of 1. So let's think about the problem if we had 1/4 of 1/5. If we wanted to take 1/4 of a fifth of something. So I've drawn out one whole. So that's this bigger blue rectangle, and it's like a birthday cake or something. And we've cut it into 5 pieces horizontally and 4 pieces vertically. And of course, 4 times 5 is 20. You should see 20 squares there in the darker blue. Okay, if we want to take 1/4 of 1/5, then consistent with what we saw on the last slide, of is like taking a part of something. So let's take a fifth out of this cake. Awkward silence. Sorry. Maybe it was peaceful. Anyway, there's one. Actually, I've got 1/4 there. Let's go with that. I needed to have one. Sorry, let me take that off. I went the wrong direction. Apologies. So 1/5 would mean that I need to cut the thing vertically. Sorry about that. All right, so here's our 1/5. I had 1/4 before. This is 1/5. That's a lot more like it. Okay, so here's 1/5 of our whole cake. And so if we want to take 1/4 of that, okay, the yellow part is 1/5 of the whole cake. We're going to take 1/4 of it. 1/4 of it, I'm going to color over in blue. That's going to turn the whole thing green, right? So this part is 1/4 of 1/5. Okay, and so think about what part of the original cake that was. The original cake, we divided 4 pieces or 4 rows and 5 squares in each row. 4 times 5 is 20. This green square is 1/20th of the whole cake. So that suggests that 1/4 of 1/5 would equal 1/20th of the whole cake. Okay, and of course, one example doesn't totally prove something, but based on that, we're going to state this helpful fact number 2 as a general. Let's say that A and B are both not zero, numbers that are non-zero. If we're to multiply 1 over A times 1 over B, you can put a 1 on top and A times B in the bottom. Again, let's try that. Here, 1/4 times 1/7. Here we're not going to actually draw it out. We're going to just use our imagination on this. Let's say that I drew out a rectangle and I divided it into 7 squares in one direction and 4 squares in another. Okay, then how many total little squares are there? 7 times 4 is 28. Okay, we would take 1/7 of it, which would be that first column that contains 4 squares. And if we took 1 of those 4 squares in that first row, that would make 1/28th of the original rectangle that we had. Okay, 1/3 times 1/8. Again, here we would have a rectangle with 8 squares in each row and 3 rows. So 8 times 3 is 24. We would have one column of 3 squares out of those 8 columns, and we would take 1 of those 3 squares out of that first column. So that would be 1/24. Okay, and so these couple of examples illustrate this. If you're multiplying together two fractions, 1 over a and 1 over b, then this gives you 1 over a times b. That is, multiply the denominators together. Okay, so I hope you're hanging in there. We are actually almost done with this. So let's take this part little by little. What we're doing is developing the formula for multiplying fractions just in general. So suppose that a over b is one fraction and c over d is another fraction, and b is not 0 and d is not 0. We can never have 0 on the bottom of a fraction, right? So forget about that. Now let's say we want to know the product of the two fractions. So we have a over b times c over d. Helpful fact number 1, which was a screen ago. Let's go back to that. Helpful fact number 1 said if you had a whole number times a fraction, you can multiply the numerator by that whole number. We saw 3 times 9 over 7 was the same as 27 sevenths. That was helpful fact number 1. Okay, so if we're going to multiply these two together, then I can think of a over b as a times 1 over b. And c over d is the same as c times 1 over d, using that helpful fact number 1. Okay, next up, we know according to the commutative property, this is why we did all that, okay, we know according to the commutative property that it doesn't matter what order you multiply in. So I had 1 over b first, followed by c. In the next step, I swapped those two. I traded 1 over b times c with c times 1 over b. Okay, the reason for doing that was just to make it so that the two fractions were right next to each other and the two whole numbers were right next to each other. Okay, so now, according to fact number 2, which was this one, which we just developed a few moments ago, that says if you've got two fractions with 1 on top, you can multiply their bottoms together. Okay, that was helpful fact number 2. So here, I'm going to take 1 over b times 1 over d, and we'll call that 1 over bd. I still have the a times c there, but we've taken that second fraction, 1 over b times 1 over d, and made it 1 over bd. Okay, and then just to finish, we're going to use helpful fact number 1 once again and say, okay, well, we have a whole number a times c. We're multiplying that by a fraction. We're going to multiply a times c times 1, which gives a times c, and we're going to put that all over bd. Okay, so if you like, you can skip all the stuff in the middle. That says basically that if you have two fractions, a over b and c over d, that you multiply their numerators together, you multiply their denominators together. And that's the rule for how you do multiplication of fractions. Multiply tops and multiply bottoms, and that's it. So there's, of course, more to it than that, things involving simplification and stuff like that, which we'll get to later. But for now, we have enough that we can try a couple of examples. So let's do that. Okay, so here we have 3/4 times 5/8. Multiply tops, 3 times 5 is 15. Multiply bottoms, 4 times 8 is 32. Got a setting on there, sorry. So 3 times 5 is 15, 4 times 8 is 32. Okay, erasing too much. All right, the next one, same. I've just used parentheses for the multiply instead of the dot, but and change the numbers, but otherwise it's okay. 7 times 3 is 21. Multiplied numerators. 16 times 4 is 64 in the denominator. Okay, this works even if they're negative. Okay, -2 times 5 is -10. And then 9 times 7 is 63. All right, just multiply tops, multiply bottoms. Okay, what if there are 3 fractions? Okay, well, remember that we have that associative property. So that says that if you want, you could do those two first and then multiply the third one, or if you like, we could multiply the second two together and then multiply that by the first one. I feel like doing this. So here we would have 2 times -4 is -8. 11 times 5 is 55. That's for the part in parentheses. And then out front, we would still have the 3/5. One more step and we're done. 3 times -8 is -24. 5 times 55 is 275. Okay. By the way, here I did this just in this sequence of steps just to kind of re-emphasize that associative property that we had. If you want to, it's totally legitimate to do it in this way. That is, just go all the way across. 3 times 2 is 6. 6 times -4 is -24. 5 times 11 is 55. 55 times 5 is 275. Okay, and that, of course, is going to give us the same answer. All right, that takes us to the end of this second video on doing multiplication involving fractions. We reviewed a little bit of a couple of properties of multiplication, and then we developed the formula for how you do multiplication of fractions. And the short answer is you multiply tops, you multiply bottoms, you multiply across, and that's it. Okay, so what we have yet to do is to see how this works if you need to do simplification and things like that. So that'll all happen in our next video. Until then, let me know if you have any questions, and have a great day.